Hi students, welcome to the chemistry sessions. So what are we going to start today is the questionnaire round, and I've got a set of 10 questions for you as per the marks which you need to perform along with me, and I'm expecting that you guys have revised the entire topic very well. Okay, so let us just start with the CBSE pattern question exercise with question number 1. And if you just carefully see over here, question number 1 to 2 is holding 1 mark. Okay, so you need to answer accordingly. What is the chemical name of dry ice? You know what is dry ice is? See, we actually have discussed this in the lectures as well. So dry ice is nothing but the carbon dioxide, and you know it has got the property, the dry ice has got the property to sublime, directly convert into the vapors, and this particular effect is used to give that gloomy effect on the concerts and the stages of that smoke coming out. Okay. So this is carbon dioxide, that is the chemical name. Okay. So as per the question asked and as per the marks, you need to just write down one liner over here. That is more than enough. Okay. Now let's move on to the next question. So the next question says, if the fish is being fried in the neighboring home, we can smell it sitting in our home as well. So basically, first of all, do you like fish or not? Yeah, I really like fish, and here what they are saying is it was being cooked in the neighboring house and I could smell it. How does this happen? What is the process behind this? So basically, all the air molecules are actually allowing those smell molecules which have come from the fish and right to my nose. So there must be, some kind of a movement going on in the molecules as well, in the air molecules, and the process which brings the smell to us is none other than the diffusion. Okay. So that is diffusion, we already have discussed. If I just spray a perfume over here in this particular corner, you will be smelling it in the another corner as well, and that is what the diffusion is. Okay. So diffusion can be in the gases, diffusion can be in the liquids as well as in the solids. I had given you a very good example related to this as well. So no need to get confused over here that solids do not diffuse. Solids do diffuse, but the process is very, very, very slow. Okay. Now, so this is diffusion, again a one-liner because it requires only 1 mark. Now, question number 3 to 5 holding 2 marks. What do you understand by the term latent heat? First thing. Second thing, what are the 2 types of latent heat? Since this is a 2-mark question, it requires more than 2 or 3 lines. Okay. Now, what do you understand by latent heat? Latent heat means invisible, right? So this is somewhere hidden, right? Somewhere hidden, or I can say just invisible. So this heat, while I was heating an ice cube, it was at 0 degrees Celsius, which is when it started melting. So at the 0 degrees Celsius, it started melting, and what happened was that entire heat while I was heating was getting consumed in moving the molecules apart to make it into a liquid, to convert it into a liquid, and that is where the heat was going. Until that time, there was no temperature change at all. I had observed it with the thermometer. It was 0 degrees Celsius till the entire cube was converted into water. And that is where the heat got hidden, got invisible in between the molecules somewhere just to make them apart, and there was no rise in the temperature. And that is what the latent heat is. Okay. Yeah, definitely I'm not going to write the entire definition for you because we already have done this. What are the 2 types of latent heats? So whenever I am melting the ice, okay, so whenever we are melting something, so in that case we have latent heat of fusion, yes. And whenever we are boiling something, we get the latent heat of vaporization. So whenever we are boiling, we get latent heat of vaporization. Got it? So this is it that you have to write in the answer, okay, as per the marks given. Now, the next thing, let's move on to the question number 4, which says, which contain more heat? 1 kg of water at 100 degrees Celsius. So I have got water at 100 degrees Celsius 1 kg at 100 degrees Celsius. And second thing, what do I have is steam. Okay, this is steam, vapors kind of thing at 100 degrees Celsius. Okay, and this steam is also weighing 1 kg. So, which is containing more heat? Give the reason for your answer. So, as I told you, how does this process actually takes place? The liquid starts boiling. Okay. So, what will happen? The water will consume heat to get converted to steam, right? And whenever steam tries to convert into water, it will give off the heat as per this particular process. That means it must be having a lot of heat, and that is why I had told you that steam, it can burn your skin, but boiling water will not be, that much effective on your skin. And that is the only reason, because heat has got a lot of heat, steam has got a lot of heat in it. Okay, getting it? So that is what the reason for this particular question is. I hope everybody is clear with the fact. Okay. Now let's move to the next question. Question number 5. What does it say? Now, why does our palm feel cold when we put some acetone or perfume in it? Okay. So let's say this is my palm. Okay, although it doesn't look like that. Yeah, but it is. So this is my palm. I added a few drops of, or maybe just sprayed a little acetone or perfume on it. Okay, acetone, again you can, all the girls out there, they can get it from the nail polish removers. Okay, so you have just spread it on your hand, and what will happen? Immediately you will feel that cooling effect, because the liquid got evaporated. So it got evaporated. So what is basically evaporation? It's nothing but the vaporization, and the liquid would have taken heat from your hand to get evaporated, and that is why we feel cold, right? Because the heat has been lost, it has been given to this liquid to get evaporated. Okay, now let me just rub this off, and let's go on to question number 6 now. Now 6 to 7 3-mark questions will be a little longer, and the explanations will also be a little longer. What are the 2 ways in which the physical states of matter can be changed? Now, I need to change the physical states of matter. What are first of all physical states? Solid, liquids and gases. Okay. These are 3 physical states of matter. How can I change solid to liquid? Just by melting. How can I change liquid to gas? Boiling. Okay, so what I am actually doing is heating. We are heating it. Yes, all in all, this is the conclusion. And if I need to convert this gas, the steam, into water, I will just cool it down. And in a similar manner, here also I will cool it down. So that is the entire process, which requires 2 processes in conclusion. That means that what are the 2 ways in which the physical states can be changed? Heating and cooling. Okay, so 2 ways are heating as well as cooling. So applying any of these, I can change the physical states of matter, and in fact I can do sublimation as well, just by heating or cooling. So what is it? By heating or by cooling I can sublime something. So basically, if there are naphthalene balls, again what is that? It is an example of sublimation product or sublimable substance. So it gets converted into vapors just by heating, mere heating. Okay, so that is the first which we have done. Now the next part, draw the states of matter triangle to show the interconversion of the states. Have you ever drawn it? So it's very easy. A similar kind of a concept will be there, but I need to just draw it in the form of a triangle. So basically it's a cycle. Let's see how. Solid gets converted to liquid. So it got converted to liquid, and liquid got converted to gas, and gas again got converted to solid. So solid to liquid, it is again heating. Liquid to gas, heating. Gas to solid, cooling. Okay. This one is cooling. Solid to gas, heating. So basically, this process over here, solid to liquid, is melting. Other way around will be freezing. Now let's move here. So liquid to gas, again what? It is vaporization. And gas to liquid, condensation. So that is the entire triangle. Now see here, gas to solid, what is it? Sublimation, right? So this entire process, basically it's cooling and heating only, but the entire thing is nothing but the sublimation. Getting it? So that is the entire triangle which interconnects, which connects all the three states of matter. Okay, so that is an important one. You can perform it once more, you can revise it once more. Now, part C, how can the evaporation of a liquid be made faster? So you know, evaporation, I actually need to vaporize some substance very quickly. So what all ways I can apply? So I've got several ways over here. I can either increase the temperature, maybe the temperature, right? Second thing, actually we have discussed all the factors initially also in my lecture. Now, temperature, or I can just increase the surface area. That means if I've got little amount of water in a glass, what I can do is just to evaporate, spread it somewhere in a bigger utensil, in a bigger container. So what will happen? Since the surface area has increased, now more of the molecules can escape out and the evaporation will be faster. So increase of surface area can be one factor. Another, evaporation, what can you do? So these two are, you know, any of these two, you can just write it down here. This is the thing that we can apply, increasing the temperature or maybe surface area. Or what you can do is, you must have seen whenever some water is spilled on the floor. So I just turn on the fan so that the process of evaporation gets faster. So basically what this fan is doing is, it is providing wind, and wind is removing all the vapors which are surrounding that spilled water, and thereby making a kind of fast process which will then promote more and more vapors to get into the air. So basically, removal of humidity, that means vapors from the surrounding air. Okay, cool. And if you want to go into the detail of this process, you can refer to my lecture for that. Now, so that was question number 6, an interesting one. 7th, what is meant by diffusion? We just have discussed. So basically, give one example of the diffusion in the gases. I have sprayed the perfume, it will go and spread in the entire room. That is how the diffusion takes place. So one gas molecule, one of the type of gas molecules will be spreading in the another, just like that. Okay, why do gases diffuse very fast? Because the molecules are itself going very fast. So that is why this process, they have the tendency to mix together very quickly. Okay, so part A done, part B done, if you have heard it. Name 2 gases of the air which dissolve in the water by diffusion. So 2 of the gases, one is oxygen, another is carbon dioxide. What is the importance of this process in nature? So oxygen must be dissolved in the water. Carbon dioxide also must be dissolved in the water. And which kind of a water? Ocean water. So you must have seen oceans and seas. In oceans there is marine life, yes, marine animals and marine plants. So the animals, as those of the terrestrial animals, land animals, or us, that we require oxygen for our survival, they also need dissolved oxygen from the water. And the plants, just like plants over here on the land, it requires, the marine plants require carbon dioxide, okay, for their survival. So these are the 2 gases which are actually dissolved, diffused in the water, so that they get provided to the required people, required species over there. Now, question number 8. Now these questions are going to be very interesting, so just pay attention over here. What all they ask, such kind of questions, I call it as mapping questions, because they have got x, y, z certain things and they have given you little hints about all those x, y, z. So you just need to find out what all substances are there. When extremely small particles x derived from the anther of the flower were suspended in a liquid Y and observed through a microscope, it was found that the particles x were moving throughout the liquid in a zigzag fashion. So zigzag fashion, what is it? Brownian motion, that's right. Okay, so as I told you, there was an activity which was performed by the scientist first who discovered this Brownian motion, that was Robert Brown. And Robert Brown, what he did was, he took some pollens from the flower, he suspended those pollens, these are very little particles which he suspended in the water. What he saw? It was also observed that the warmer the liquid, he warmed the liquid a little bit, the particles, the pollens seemed to be moving very faster. So faster the particles moved on the surface. So we know this fact. Let us just try to answer the questions. What could particles X be? Pollens. So these are pollens. What do you think of the liquid Y? It is water. Yes, as simple as that. What is the zigzag movement of X known as? It's the Brownian motion. We have already answered that. Brownian motion. Now what is causing the zigzag movement of the particles? So it's basically what? The movement, the vigorous movement of the liquid, the water molecules which are carrying those pollens, and that is what is causing the particles to move. Getting it? So here are the liquid molecules. Okay, now so basically what is the thing behind it? It's nothing but the Brownian motion again. Name the scientist who discovered, that is the Robert Brown who discovered this phenomena. What does the experiment tell us about the nature of the liquid Y? What does it say? It tells us that this liquid, all that seems to be transparent, all that seems to be colorless, but it has got molecules which are moving randomly in different kind of directions and different kind of zigzag motions, and that is why we call it as a Brownian motion. Okay, that was discovered by the scientist. That is why this phenomena has got this name. Okay, otherwise it's nothing but just the zigzag fashion of the molecules, how they travel along. Okay, now so that was question number 8. I hope everybody has followed and got it. Now the question number 9. Now it's a 5-mark question, going to be very interesting, so just pay attention. There are 4 substances X, Y, Z, W. The substances W is dark violet, okay, W is dark violet, solid having diatomic molecules. Diatomic means 2 atoms are combined, let's say X atoms, okay, what is it? W is there, okay, having, yeah, so not X, let's assume it W only because it's given in the question. So W, 2 molecules are combined, W2, this is the molecule, I don't know what W is. A solution of W, now they have given the hint to it. The solution of W in alcohol is used as a common antiseptic, and you know what this common antiseptic is? This is tincture of iodine. Tincture of iodine is iodine dissolved in alcohol and water to make it an antiseptic, that is used in the surgical operations as well as used by the doctor usually, right? You must have gone to the doctor, he must have applied that brownish colored thing on your hand if you got hurt. So that is nothing but the tincture of iodine and antiseptic. Okay, so this is tincture of iodine, and I have got it that W is nothing but I2, and you know it is dark violet in color. Now you have got another information about iodine. Next, the substance X is a white solid which is recovered from seawater. Now this is the another statement. So it is the white solid which is recovered from the seawater on the large scale. What is it? It's nothing but the salt. So X is, which is NaCl. Salt is recovered from that salty water of the ocean. Okay. The substance Y is a white solid which is insoluble in water, used in the form of small balls for the safe storage of the woolen clothes. What is it? You must have seen those naphthalene balls, is it? So again, it is used to store the woolen clothes. You must have seen your mother putting those balls, little white colored balls, in the clothes just to protect them from getting spoiled. And that is what the naphthalene balls is, and why is naphthalene. The substance Z is yet another white solid used in the dry cells. Now what is it? Okay, let's try out here. So what they are asking is name first W, X, Y, Z. Okay, W, X, Y, yeah, this must be Z, right? Just make a correction over here, this is Z. Out of W, X, Y, Z, which substance undergoes sublimation? I know it, it's naphthalene and it is substance number Y. Okay, now which substance is organic in nature? Naphthalene is organic in nature. Okay, this is not, these are inorganic substances. Naphthalene, it contains carbon and that is why it is organic in nature. So this also is Y. What is the name of the substance? C. Okay, just wait. Yeah, so it is used as a common antiseptic C, and I have got the name for this common antiseptic C, that is tincture of iodine. Which substance belongs to the halogen family? And this is the halogen family. What I am left with is the substance Z is yet another white solid which is used in the dry cells. I am not going to tell you because we already have discussed such kind of questions. Okay, so just try it out yourself. If you've got any doubts, you can reach out to me. Now, question number 10. When water is cooled to a temperature X, it gets converted to ice. Okay, so water is X with some temperature. Okay, yeah, water with some temperature X got converted to ice, gets converted, okay, by a process called P. What is this process? Water I am converting to ice, it's none other than freezing. Yes, it is freezing. Okay, now and when ice at temperature X is warmed, it gets reconverted to water at the same temperature X. It got reconverted, and this is what? Heating. Okay. Now, with a process called Q, what is the value of the temperature X in Kelvin? Now, have to be very careful. X is 0 degree, we know. That is at this temperature only it gets converted into ice. And 0 degree can be converted to Kelvin by adding 273. I get the value as 273 Kelvin. Okay, so here it is 273 kelvins. What is the P process? We have already got it. It is freezing. Okay, so that is freezing. What is the name of the energy released during the process P? So here P process, that means water got converted into ice. It must have released heat energy, right? And that is why ice is getting cooled down. So here the energy will be heat energy. What is the process Q? It's heating. What is the name of the energy absorbed during the process Q? Again, it's heat energy. So ice must have absorbed a lot of heat and got converted into what? Water. Simple. So here also the answer has to be heat. Okay, and that completes my entire set of 10 questions. I hope everybody's enjoyed, everybody has revised. I am hoping that the entire chapter have been revised through all these 10 questions. You need to practice out these once more. Again, if you've got any doubts, and yeah, one question I've left it for you guys, okay? That is quite simple. You have to try it on your own, and I'll be dealing with the doubts as well. So you can reach out to me anytime. Have a nice day.